have knowledge of even and odd signals, and we can also calculate the even component and the odd component of a continuous time signal. In this lecture, we will explore various properties of even and odd signals. This lecture is very important. This particular lecture is very important because by using these properties, we can save time while solving the problems. In the first property, we will calculate the even component and the odd component of a DC value. Let's say the DC value is equal to 10, so xt is equal to 10. I will plot the waveform when time t is greater than 0. The y-axis is for xt and the x-axis is for time t, and when time t is greater than 0, or we can say when time t is positive, this is the waveform of xt. And to find out even component and the odd component, we need x minus t, and we can easily obtain x minus t by performing the time reversal or folding. So in place of t we will have minus t, and we need to find out the waveform when time t is less than 0, or we can say when time t is negative. You can see xt is equal to 10 for all the values of time t. So we will have the waveform like this when time t is negative. This waveform is for x minus t, and this waveform is for xt. And when we compare the two waveforms, we can clearly see they are mirror image about the y-axis, or we can say they are symmetrical about the y-axis. So after performing the time reversal, the two signals are symmetrical about the y-axis, and this is the property of even signals. And we can also see xt is equal to 10, x minus t is also equal to 10. So xt is equal to x minus t, and this is the property of even signals. Therefore DC value is an even signal, and whenever any continuous time signal is purely even, the odd component is simply equal to 0. So the odd component x ot is equal to 0, and the even component x et is equal to the DC value, and in this case DC value is equal to 10, so the even component is equal to 10. We can also calculate the odd and even components by using their formulas. X et, the even component, is equal to 1 by 2 inside the bracket xt plus x minus t. So we have 1 by 2. 10 plus 10 is equal to 20, so we will have 10 as the value of even component, and the odd component x ot is equal to 1 by 2 xt, the original signal, minus x minus t, the signal after performing the time reversal, and this is equal to 0 because xt is equal to 10 and x minus t is also equal to 10, so 10 minus 10 is equal to 0. So this is very important property regarding the DC value. Now we will move to the next property. In this property, we will talk about the outcome when we add the even signal to a DC value. So what will happen when we add even signal to a DC value? We will try to find out. Let's take one example to understand the outcome. 10 plus t square is equal to xt. Here 10 is the DC value and t square is the even signal. When we perform the time reversal, this means when we obtain x minus t, then we have 10 plus minus t square. Minus t square is equal to t square, so we have 10 plus t square, which is similar to xt. So x minus t is equal to xt. So this case DC plus even will produce even signal. One more thing you can see from this result, DC value is an even signal. So here we are performing the addition between even signal and the even signal. So sum of two even signals will give us even signal. So in this property we have two results. DC value plus even is equal to even, and even plus even is also equal to even. Now we will move to the third property. In the third property, we will add odd signal to a DC value. We will add odd signal to a DC value, and we will again take one example to understand the outcome. Let's say signal xt is equal to 10 plus t raised to power 3, and we will perform the time reversal. So we have 10 plus minus t raised to power 3, and we already know minus t raised to power 3 is equal to minus t cube. So we have 10 minus t cube. So this signal is neither even nor odd, because condition of odd signal is x minus t equal to minus of xt, but 10 minus t cube is not equal to minus of xt. It is not equal to minus of xt, and it is also not equal to xt. So when we add odd signal to a DC value, we will have neither even nor odd signal. We will have neither even nor odd. So third property is about the addition of odd signal to a DC value. There is one more thing in the third property. DC value is an even signal, and when we add even signal to a odd signal, the result is neither even nor odd, and this is something we have already discussed in the last lecture. I told you a general continuous time signal is neither even nor odd, and because of this we can represent a general continuous time signal as sum of even component and the odd component, and this is the proof of this statement. Now we will move to the fourth property, in which we will talk about multiplication. In the fourth property, we will talk about multiplication. What will happen when we multiply two even signals? I will represent even signals by capital E, and I will represent odd signals by capital O, and we have to find out the result when we multiply two even signals. We will take one example. In this example, signal xt is equal to t raised to power 2 multiplied with t raised to power 4, and this is equal to t raised to power 6. T raised to power 6 is an even signal, because when we perform the time reversal, we will have minus t raised to power 6, which is equal to t raised to power 6. T raised to power 6 is equal to xt, so x minus t is equal to xt. So t raised to power 6 is an even signal, and whenever we have even power, the signal is going to be even. So t raised to power 2 is also an even signal. T raised to power 4 is also an even signal, and when they are multiplied, the result is also an even signal. So in property number 4, when we multiply two even signals, the result is also going to be an even signal. In the fifth property, we will multiply two odd signals. When we multiply two odd signals, the result is going to be an even signal. Let's try to understand this by the help of one example. Signal xt is equal to t raised to power 3 multiplied with t raised to power 5, and this is equal to t raised to power 8. T raised to power 8 is an even signal because we are having even power. T raised to power 3 is an odd signal because we are having odd power. T raised to power 5 is also an odd signal, and multiplication of two odd signals will give us even signal. In sixth property, we will multiply odd signal to even signal, and let's try to find out the result by the help of this example. Signal xt is equal to t raised to power 3, the odd signal, multiplied with t raised to power 6, the even signal, and the result is equal to t raised to power 9. The result is having odd power, so multiplication of odd and even signal will give us odd signal. In the seventh property, we will differentiate the even signal. In seventh property, we will differentiate the even signal. Differentiation of even signal will give us odd signal, but there is one exception. This property is not valid for DC values. DC values are even signals, and differentiation of DC values, for example, when we differentiate 10, we will have 0, and 0 is not an odd signal. So this property is not valid for DC values. Now we will move to the 8th property. In this property, we will differentiate the odd signal. Differentiation of odd signal will give us even signal. In the ninth property, we will integrate the even signal. Integration of even signal will give us odd signal. In the 10th property, we will integrate the odd signal. Integration of odd signal will give us even signal. In the 11th property, we will find out 1 by odd signal. 1 by odd signal is simply odd signal, and the last property is 1 by even signal, which is equal to even signal. So these are the properties of even and odd signals, and by using these properties you can solve various problems related to even and odd signals. I hope even and odd signals are now clear to you, and if you have any doubt you may ask in the comment section. In the next lecture we will solve few examples based on even and odd signals. So see you in the next one.